So how does your typical day start out?
Yeah, so normally I'll get into work at probably 7 a.m. to 7:15 a.m. Then I'll instantly start checking emails. After that, pretty much I'll go through all my emails and sort by priorities. So if I've got any current projects that I've been getting emails on, I'll shoot those into my priority inbox. Any other ones that I can kind of look at later in the day, I'll just leave on unread. And then after I've searched through all my emails, I'll kind of go through and start doing a lot of the administrative work that I get assigned. So a lot of the AutoCAD kind of drawing updates, the trivial stuff, and kind of the PSI management stuff, and kind of doing just all that engineering administrative paperwork.
When you're looking at the AutoCAD drawings and stuff, what exactly are you doing in AutoCAD?
Yeah, so basically anytime we get either a complaint for a customer or any sort of possible update to a small, tiny update to a drawing or a part number, let's say a vendor stops being able to source a part and we just switch that part for a specific different part. Basically, all that would be going into the actual drawing itself and making sure that I redrew that new part in order to get the referencing correct. So that would be an engineering change order or engineering change request. And that would be something like either there's a customer noticed an issue in the field that we need to address, or there's a vendor issue, just anything that needs to be changed from an engineering perspective on the drawing after I've initiated that ECR or ECO. Then the next step in that process would be me updating drawings.
Does that happen a lot?
Yeah, pretty frequent. Well, especially because we're such a small company and we don't have a huge testing facility, so a lot of the problems that we do see kind of do occur in the field every once in a while. So yeah, it's a pretty frequent issue, yeah.
Could you give us like an example?
We've been using a specific model of pump for basically since the company started about 3 years ago. And 8 months ago, there was just a really kind of off-the-hand interaction between our head engineer, my boss, and their engineer, where their engineer basically said, hey, we're switching the gasket seals on this pump to a different compound. Is this going to be okay with whatever current implementation you're using? And it was a very kind of brief back and forth. My boss was like, yeah, as long as it can handle ethanol and biocompatibility with terpenes at minus 40x, it's fine. And he kind of confirmed that and it was okay. And then 2 months later, all of these pumps started kind of blowing up and freaking out. Basically, that update that they made themselves was an issue with their pump that we basically weren't allowed to use that pump anymore. So we had to switch to 2 different vendor of pumps. And then so at that point, that would be an ECR, ECO. We saw that the old pumps in the field were breaking. So a customer would tell us that. I would then say, all right, I need to initiate an engineering change request, which would be, hey, there is a problem out in the field. I describe the problem and then describe the engineering solution that would fix that. And then I would basically submit that as a request to all of the people and to my boss. And then if that was approved, I would start an engineering change order. And that engineering change order would basically say, this is the change that we implemented. So in the case of the pumps, it was switching from vendor model X part to new vendor model X part, and then an optional vendor model another part. And then I would update that in anything related to that actual system itself, which is mostly just drawing. And then I'll take lunch for probably 10, 15 minutes. I'll normally just go out, grab something, and come back and eat at my desk. And then after that, I will do actual design work because I kind of get a little stir crazy after just sitting at the desk and doing not thinking work for a couple hours. So normally I'll open either a modeling program that I was using for design. So in the initial phases, I'd be doing a lot of basically chemical modeling. So whenever I was trying to choose which solvents I would be using to separate whatever compound I was looking at, I'd just basically be building molecules and running simulations and then doing basically computer experiments that way for a couple hours doing that.
So what's your most current project or experiment that you're working on?
Yeah, so originally when I first started the system, there was for all the research I was doing, basically people said, in order to get a solid biphasic separation solution, you should use the ChemWatt system, basically a mixture of 5 different solvents that some guy developed and said if you change the ratios of these solvents to different ratios, then you can fine-tune that and get perfect separation with an unlimited amount of compounds pretty much. So what I would do is I'd start with those 5 solvents as a base, see how they interact with each other with that computer modeling software I did, and kind of gauge those interactions. But I'd kind of see that and then notice what kind of changed in those concentrations of solvents I was talking about. basically run that model again, see the change, and basically just keep tweaking ever so slightly concentration to get perfect separation.
But the end goal is to separate like THC and CBD, is that correct? Or?
Yeah, so if you got, let's say, a 50% THC, 50% CBD gloss that you just kind of dump into a beaker that had, let's say, layer 1 was acetone, layer 2 was heptane or something, and you shook all those things up and you kind of let them mix and then resettle out, there would be a higher concentration of CBD in one of the layers and a higher concentration of THC in the other layer. And that's how you're kind of doing the separation. So my design was a little bit different because it's basically doing that thousands and thousands of times to achieve perfect separation, because you can't actually get perfect separation just by shaking something up and splitting it out. So basically my design was you do that exact same thing where you shake it up and then separate out and shake it up and separate out at a differential level multiple thousands of times. And that's how that was my idea of how to get separation. And then if it was a day where I had access to a lab, I'd grab all of my data that I would take there, basically get everything, and then after lunch go straight to whatever lab we had access to that day, and kind of crank down and get as much actual testing done as possible. So we normally really only get 1 or 2 days of lab work a week. And then normally I'd stay there till 5, 6, 7 p.m. just to kind of get as much as possible. And then after that, I'd spend the day right after that, or the night right after that, kind of re-looking at everything and then basically re-updating design.
So what are you doing in the lab? Are you just basically doing the same simulations you were in the computer, but now in the real world in the lab?
Yeah, a lot of the early design stuff, so because we never actually got our own lab, we never got super far into heavy-duty design stuff, but basically what I would do is I'd take the exact concentrations that I would model on the computer software and then run multiple tests, basically just confirm the accuracy of the computer model, and then try and figure out standard deviations of kind of what that is to give me a good gauge. Basically, I would use testing to try and maximize the viability that I could use for the software. I was using testing less for actual design and more testing for proving the theory of the software, just so I could be confident in the design itself.
And what's like the end goal? Is it just to like create a better, more efficient way to separate THC and CBD, or?
Yeah, so right now there's really only one way to separate THC and CBD. Because there's only 2 ways to separate pretty much anything that is by boiling point or polarity, because CBD and THC are pretty much the exact same compound, except one of them just has an open carbon ring. That makes their boiling points pretty much the exact same, so it's impossible to distill them. So the only other option is separation by polarity, which is chromatography, and that chromatography system. But effectively what it is, the 2 solvents have a slightly different polarity, and because of that, they'll grab CBD or THC, and that's pretty much the only way to actually purify CBD or THC, because they're so close together from a boiling point standpoint.
So it sounds like in the CBD industry, chromatography is an important aspect of it.
Oh yeah, chromatography right now is pretty much the industry standard for CBD THC separation. Most chromatography that people are using right now is high performance or high pressure flash or liquid chromatography or flash chromatography, which is basically just a really big column filled with silica beads that are kind of tailor-made to have a specific charge. And then what you would do is have a solvent that you would dissolve, let's say your CBD THC compound mixture in, and then you'd basically pressurize that column and then flow that entire solvent CBD THC mixture through this kind of column filled with silica beads. And those silica beads are acting as basically like a polar charge to slow down or speed up some particles. So at the end, you're getting a pure THC or pure CBD compound. In principle, the same theory as what I was talking about, except instead of using a silica bead and a liquid solvent, I'm just using 2 liquid solvents that can't mix together.
So when you're going into the lab and stuff, is there anything like have you ever seen anybody have like spills or burns or anything like that? Because sometimes I think like with the lab, it's like, oh, you need to be careful.
Yeah, so probably the first month or so that I was working for this company, we were just testing out one of our new extraction systems, which is basically just a bunch of really cold ethanol that recirculates into a chamber, and as it's recirculating, slowly pulling out CBD and THC from biomass. So we were testing that, and basically we had it set up to where we were feeding it back into this tank, and basically the reflux feed back into the tank, or I forgot to clamp it all the way down. So as we started recirculating, the hose came off and basically shot ethanol all over the place, and that was really, really horrifying.
Wow.
And so that was a pretty big bill, especially because ethanol is so highly flammable. That was a really bad one. So basically we instantly shut everything down with emergency power and then just kind of left the room, let it air out for 20 minutes or so, and then we just cleaned it all up, and that was that.
Oh, wow. So you got to be super careful, like when you're in the lab and when you're doing...
Yeah, especially in this industry, because pretty much every solvent you're working with is a hydrocarbon. They're all have super, super low flash points, especially pentane. So pentane is one of the solvents that works really, really well with chromatography, but it boils off at 36 feet. So even if you leave it at room temperature, if there's any sort of open flame, it'll instantly ignite, and its auto ignition temperature is like 100 feet. So it's really, really dangerous stuff. So yeah, you got to be really, really careful.
Wow, that's interesting. And I mean, is there anything else you need to know when you're in the lab? I would imagine that like you need to have some sort of like attention to detail.
Yeah, I mean, the biggest thing with anything in a lab, so any chemicals you're working with that day, print off the SDS, the safety data sheet of that exact chemical, and it'll give you an overview of how that chemical interacts with, like, how toxic it is to your body, how flammable it is, or how bad it is with the environment, and it basically gives you a report for that. And so every single day, whatever chemical you're working with before you enter the lab, you read the SDS sheet, and that tells you exactly what you need to worry about with that chemical.
So besides your AutoCAD work and your design work on the computer and the actual design and testing in the lab, is there anything else that you do over the course of a week or a month?
We do basically a review meeting every single Tuesday that would normally take like an hour and a half, where everyone just goes around and says what the progress is for that specific department that week. But kind of in addition to all that stuff, I pretty frequently go out and do either equipment installs or troubleshooting at client sites. So probably once a month or so, I'd probably be flying out to a different state or driving out to troubleshoot or install some of our equipment on site.
You said earlier that you guys don't do any actual like CBD extraction and that you just kind of like make the equipment, but do you ever have to like test it? Do you ever have to test the equipment using cannabis or?
Yes. So yeah, every time we're doing any sort of testing, we are actually running the equipment. So any R&D design stage, we are running stuff through and making sure all of our parameters are correct before we ship it out. It's just when we actually have that design locked in, we're not really to be running anything else through that system ever again on our end once we know that the system works, basically.
Have you ever had an example where you send your system out after testing it and then you run into issues in the field?
Yes. For example, one of our systems was a decarb column, which basically all that does is it's a chemical reaction that converts the acidic form of CBD into regular CBD. And so when we initially designed that, we ran it through and we came out and we had like a 99% conversion rate, let's say, so it was fine and we shipped it out. And then a couple months later, we got a customer say, hey, we're only getting a 93% conversion rate from CBDA to CBD. What's going on there? So then at that point, we did have to go back and basically change the parameters to get that conversion percentage back up. And that was an example where we did need to go back and retest and reevaluate.
And when you say you had to change parameters, what exactly does that mean?
So we had to, basically what it was, so it was a shell and tube, basically heat exchanger, and we increased the surface area by changing the diameter of the tubes and the amount of tubes in there, basically just to get the right amount of heat into the system to have the chemical reaction get to a full conversion.
Did it take you a long time to figure that problem out, though? It sounds like that could have been tricky.
Bad because basically the design in theory was already in place. All we really had to do was the reason that they weren't getting a great conversion rate is because they were doing various flow rates that were kind of screwing with our system. So all we had to do was just add in an extra factor of not safety, but a factor of usability, I guess. Basically just increasing the total surface area to get it right. It wasn't super dial-in scientific. It probably took a week and a half to get it good to go.